We're going to write a program to multiply some integer by 5. So we will input an integer and then multiply it by 5 and then output the result. So in this example, the integer that we input was an 8. We multiply it by 5. Hopefully we get 40 and we output the result. But how are we going to do this? We look at the possible instructions that we have. What can we do with the accumulator? We can add, subtract, shift, rotate, AND, OR, XOR, and that's about it. We don't have any instruction to multiply, but somehow it has to be done. One possibility is to add. So if I have 8 plus 8 plus 8 plus 8 plus 8, we get 40. So we could put our number first in memory, then we could put it in the accumulator, and then we can add from memory. We can add another 8 and then go to memory to get another 8 and add that, and then go to memory and get another 8 and add that to the accumulator, and then the last time go to memory and get another 8 and add that to the accumulator, and then output from the accumulator, or rather store from the accumulator, store it into memory, and then output from memory, and there we have the answer. Well, thank heavens it's only 5, because if it were multiplying some number by 16, I would be here all day until I learned how to loop, and looping is not that easy either. There must be an easier way, shorter way at least. Let's think about that. If we shift ones to the left, we multiply by 2. So if I'm going to just erase what I have here. If we put that 8 from memory into our accumulator, and then we shifted left, that would be multiplied by 2. We've now got 16, and then shift left again, that's a multiply again by 2. So altogether I've multiplied by 4, and then add my 8. Now I've got the 40 that I wanted, which I can store and then output. So if I shift twice to the left, I'm multiplying by 4, and that seems to be an easier way to do it. So let's go to PEP8 and let's think what we said our algorithm was. It was input my integer, meaning to memory, load it into the accumulator, arithmetic shift left, that multiplies by 2, and then another arithmetic shift left. So now I've multiplied it by 4, and then I want to add to accumulator my number. Let's just say add my integer to the accumulator. So now that's multiplied by 5, and then store in memory, and then output from memory. Okay, we think that does it. Our program starts out at address 0. Let's see what we have to look up in our table. We need to look up input decimal, load a register, arithmetic shift left, add to the accumulator, store, and output integer. Okay, let's look up some opcodes. I looked up the opcodes that we needed and put them down here. In each case, our AAA is 001, and in each case, we are using the accumulator, which is register 0. So the first thing we want to do is input to memory, and I need to know the address where this instruction lives, and it lives at 0000. And what is the instruction? Input decimal number is 31. So 31, and then input to where, so I need a location, which means I need another 2 bytes. So this instruction totally takes 3 bytes, which means that the next instruction in memory will be at 3. So this is 0, 1, and 2, and the next one starts at 3. And load into the accumulator. So a load is a C1. So C1 from somewhere, figure out where later, into the accumulator. So 3, 4, 5, this next one starts at 6. And the instruction is 1C, and it just takes 1 byte. There's no memory location, it is an operation on a register, shift. So the next instruction is going to start at 7, because this one was only 1 byte, so 6 and now 7, which means the next one starts at 8. And it is an add, so that is a 7-1 followed by add what, or from where. So I need a location. So that is 8, 9, and A. This one therefore is B, and it is a store, and a store is, we see it down here, E1, store someplace, and then so that was B, C, and D. Which means that this one starts at E. And that's an output. So 39 output from somewhere. Let's take a minute to make sure that our addresses are correct. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 1, 0. So the next one is going to be 1, 1. And I'm done, so that's my stop. Which means the next one is 1, 2, and that's my byte I needed to store my number. So that's 1, 2, and 1, 3. 1, 4 is for my result. 1, 4, and 1, 5. And I'm done. So now I have to work out these addresses. I get my integer and I put it to memory. Where did I say I would put it? 1, 2. And then I would load it from 1, 2 into A, arithmetic shift, add the number that's at 1, 2, store it. I said I would store it at 1, 4, and output from 1, 4. And now I put my instructions, not the comments and not the addresses, into my object code. Here we have it in the object code, and I put my ZZ at the end. Here is my 8. Let's run this. Build, run object. And here is my 40. Let's try a different number. 12. Build, run object, 60. So let's take a minute to look at the memory. Let's go to View, CPU, and Memory. And if I look here at the right hand side in our memory dump, I can see my program written here in memory. I can also see the contents of the CPU here. So let's try a different number. Let's try 10 for a minute. And let's go to Start Debugging Object. And we can single step through this. So it's going to work on the first instruction. And when it does that, you can see in red here, it's put 0A into location. Let's work this out. This is 10, 11, 12, and 13. And 12 and 13 is these 2 bytes here that I kept to put my input in. So good so far. Our accumulator, that has the 0 from before. Sorry, our accumulator has the 60 from before. My next step, I have put the 10 into the accumulator. I'm sorry, I cannot make this bigger. But I put the 10 into the accumulator. You can run this and check it yourself. And it's showing here that the next thing to be done is the shift. So if I do a single step, my accumulator has a 20 in it. So I have multiplied it by 2. And if I single step again, my accumulator has a 40 in it. And I single step again, and my accumulator has a 50 in it, because I just added the 10 to the 40. And now I single step, and I have just put my number 32 in hex. I can multiply this out. 3 times 16 is 48, plus 2, 50. So 32 is 50 in hex, or 32 in hex is 50 in decimal. It just put that down in storage and then output. So you can watch your program running. You can see things being put down in memory. You can look at the contents of your registers as you go through. You'll probably have to do this when your program is not correct. We don't always write perfectly correct programs the first time, so you probably have to get used to doing this, but it's a great tool that you can see everything in memory and everything in the CPU. When you save this program, I think I forgot to say this before, let's try saving this. So you go up to File and you save object, because it's your object code you want to save. So don't try saving source, because that doesn't save your object. So save object as, and what shall I call this? MultBy5.